Hello everyone, welcome to the mathematics on my channel. In this video we are going to solve the same integral from 0 to infinity sine cube of x over x cube. So in the previous video we solved this integral by using Laplace transform. So this video I'm going to I hope to use triple integral. Okay, let's see the elegant solution of this interesting integral. Well, first I'm going to rearrange sine cube of x over x cube like sine square of x over x square times sine of x over x dx. Okay, then here integral from 0 to infinity sine square of x over x square, then here sine of x over x. So instead of sine of x over x, I'm going to represent sine of x over x by using definite integral from 0 to 1 cosine of x y dy, and here we know we have dx. Well, then we can switch the integral signs. So here first integral from 0 to 1, then integral from 0 to infinity. Here we have sine square of x over x square, then cosine of xy, and here we have dx dy. Well, then here we have sine square of x. So we can again rewrite integral from 0 to infinity. Now instead of sine square of x, we have the trigonometric formula 1 minus cosine of 2x over 2 we know constant, so we can write outside of the integral sign. So here x square, and then here we have again cosine of xy dx dy. Okay, then now 1/2 integral from 0 to 1, 0 to infinity. Now we can multiply 1 minus cosine of 2x by cosine of xy. So we have cosine of xy minus cosine of xy times cosine of 2 times x over x square dx dy. Well, then 1/2 integral from 0 to 1, integral from 0 to infinity. Here cosine of xy, but here we have product of two cosines. So we know in high school maths we learned we can represent product of two cosines by sum of two cosines. So we have 1/2, so here minus 1/2 cosine of now sum of these angles. So we have x, we know common factor, so here x times y plus 2 plus, then here subtract, so we have cosine of x times 2 minus y. Then here in the denominator we have x square, and here dx dy. Okay, then here these two we can simplify. So here 1/4 integral from 0 to 1, integral from 0 to infinity. Now here we have, if we take the common denominator, we know we have 2 times cosine of xy minus cosine of x times y plus 2, then again minus cosine of x times 2 minus y, then over x square dx dy. Okay, then I'm going to rearrange this part here 1 over 4 integral from 0 to 1 integral from 0 to infinity. Now here we have 2 times cosine of xy, but I get 1 cosine of xy, then minus cosine of x times y plus 2 over x square, then here plus here we have 2 times cosine of xy, so we have another cosine of xy, then minus cosine of x times 2 minus y over x square, then here we have dx dy. Okay, as a next step, here 1 over 4 integral from 0 to 1 integral from 0 to infinity. Then instead of this part and this part, again we can use another definite integral, because we know if we integrate from y to y plus 2 sine of xt over x, we have this part. So here we know we have again y to 2 minus y sine of xt over x dt times dx dy. Okay, then here parentheses. Then again we can rearrange the integral sign. So we have 1 over 4 integral from 0 to 1, then integral from y to y plus 2 integral from 0 to infinity sine of xt over x dx dt plus here y to 2 minus y integral from 0 to infinity sine of xt over x, then here dx dt parentheses, then here dy. Okay, now integral from 0 to 1, then here y to y plus 2, and we know this is a well-known integral, we solved many times. We know this is equal to pi over 2. So we have here pi over 2 dt plus y to 2 minus y. Again here we have pi over 2 dt here dy. Okay, here now pi over 2 constant, so we have pi over 8 integral from 0 to 1. Now if we integrate, here we have 1, so t, so if we at the same time we can plug in boundaries. So we have y plus 2 minus y plus here also 2 minus y minus y dy. Well, then we know this y get cancelled, here pi over 8 times, now we have here 4 times 2 minus 2 times y, so we have integral from 0 to 1 4 minus 2 times y dy. Okay, then we can integrate, if not we can get 2 as a common factor. Okay, anyway here now we have 4 times y minus 2 times y square over 2, and these 2 get cancelled. Limit from 0 to 1, so if we apply limit we have 4 minus 1 3, so 3 times pi over 8. Okay, if you like this type of videos, please subscribe this channel. Thank you for watching.